Okay, so let's go through drawing some of these ellipses that you need to be able to draw and compare them. Okay, so this is what your lab looks like. And we have some tacks right here. So you have to grab two tacks. I will use the first two that I grabbed. Doesn't matter the color. Don't poke yourself with them. And you're going to be given two loops of string. And it doesn't matter which two. Just for any two loops of string that you have to see which one is larger than the other. Try to grab two, like those two are pretty close in size. So you just grab two different loops until they are different in size. So you can see that when I do this here, this loop right there is obviously a lot smaller than this loop there. Okay. Now you're going to follow the instructions on each piece of paper on how to draw the ellipse. So I am going to follow different instructions as far as how far apart to set certain things. What you want to do when you do this is just fold it so one piece of paper is out and the rest are over here off to the side. Okay, that'll make things easier to work with. Now we're going to compare this ellipse that we draw to Mars. What's the eccentricity of Mars? So the first step you have to do is look over here and you find your eccentricities. Mars has an eccentricity of 0.093. What does that mean? We'll go over it in a bit. 0.093. So that's how eccentric Mars is. We've got to draw ours. Okay. This says to do it 3 centimeters apart. That's what you'll do. I'm going to do mine 1.5 centimeters apart just to mix it up. So first thing I do is I grab a ruler. And when I grab this ruler here, I'm going to go roughly towards the center of the paper, the whole paper, not just this bottom part here. And I'm going to make 2 dots, 0, and I'm doing 1.5 centimeters apart. Okay. So that distance right there is 1.5 centimeters from there to there. Now, if I pause before I draw my ellipse and I come back here, that's called my distance between foci. So the focus, there's 2 focuses, which are called foci. 1.7, 1.5. I can't read. Okay, so I've got those two. That's where I put my tacks. Put the tacks all the way in. Don't leave them up at all. Put them all the way in. Right on the 2 dots. Those are the 2 foci. Hey, look at that. One of them's yellow. That's going to be important in a bit. Put my string on there. You have to accurately draw this. So you can't just start drawing however you want. You've got to pull the rope taut. Not so tight that the tacks come out of the board, but you keep some pressure on there so it makes a complete, full, of course it went right off the board. So I'm going to have to do this again. This is a common issue. That's a terrible drawing. Don't do it that way. All right, let's go through one more time. Mr. Spado messed up. Of course, that happens on the video. But I might as well show you that mistake. That is a really common mistake. So let me get a little bit more accurate with the center of the page. Okay, the center of my page looks like it's about 13, right about there. Center of the page, about there. All right, so that's about my center. I need 1.5 apart. 0, 1.5. So that's my distance between foci. That was 1.5. I put my 2 tacks in. Put my string on there, and I keep the string taut. So I'm going to draw this ellipse. It doesn't matter if it goes off on the bottom. That's okay. Bottom and top does not matter at all. Okay, so you can see it went off on the bottom, went off on the top. That's actually not going to matter at all. What we need to do is we take our tacks out. Okay, we measured the distance between foci, and we put that on the front. The other one is called the length of the major axis. So that's how wide this ellipse is. It looks like a circle, but I've actually got to measure from one side to the other. And I go right through the two foci. So I'm making sure that that 0 is on there. And I go to my nearest tenth. This looks like it falls exactly on the 22. So I'm going to put 22.0 centimeters. Okay. But I would go to the nearest tenth, wherever that happened to fall. So I come over to here. Okay. And then to get my calculation, what is my eccentricity or eccentricity? Okay. My formula is right here. Distance between foci divided by length of major axis. So I divide this by this. Hey Siri, what is 1.5 divided by 22?
The answer is approximately 0.06818.
0.068. You round to the nearest thousandth. So these should say to the nearest tenth you're going to round to. And this is to the nearest thousandth. Okay. So now I have the eccentricity of this asteroid that I just drew. So this asteroid is 0.068. We originally did this for Mars, but since I had to use a different sheet, let's find Earth's eccentricity. Earth's is 0.017. 0.017. Okay, so this is how I do all of this. Earth's is this. This is this. Which is more eccentric? There's going to be two numbers. 0, which is a perfect circle, and it can go all the way up to 1, which is a perfect not circle. It's a perfect ellipse. 1. So the numbers 0.000, 1.000, and as the numbers get closer to 1, they get more eccentric. So the ellipses would start looking less circular, less circular, less circular, less circular, less circular, all the way down to a perfectly flat nothing. Okay, this number, this is closer to 1. So mine is more eccentric because it's closer to 1. Okay, so that's how I do that. Then I have to mark the sun. The sun could be at either of these locations, doesn't matter which. You mark off the sun. Okay, and the asteroid is moving the fastest. As the asteroid goes around the sun, wherever it gets the absolute closest to the sun is going to be where it goes the fastest. And you could take the time to measure all the way around the circle to see where it's going to be closest. But it would be closest right there where it exactly lines up. And I would put an X right there. So that's where the asteroid's going the fastest. Distance between foci, length of major axis, and you compare 0 to 1. Closer to 0 is a circle, closer to 1 is more eccentric. Now I'm going to draw some more ellipses on a couple more sheets, and you're going to do some practice questions for the next couple of daily assignments based off of what you see me draw. I won't say too much, but you're going to watch me draw these things and use the measurements that I give you. I'm just going to put the ruler up, and you have to make the measurements to get your answers. Okay. So for this one is getting compared to Venus. This is ellipse number 3. This is not the ellipse number 3 that you have on your lab. I'm just doing some random ellipses and drawing them, showing you the ruler, and you've got to measure. Now it's important to watch as I'm drawing these. I'm keeping this string taut the whole time. If there's any squiggly loose drawings, it would be wrong. So look right at that best you can. If you need to zoom in, you can get your measurement there to the nearest tenth. I go right through these two here. You can get your measurement there to the nearest tenth. You have to come up with these. These are some answers you're putting on your daily assignments for ellipse number 3. Do your calculation. Eccentricity of Venus, compare the two. Okay. I draw my sun. So if I give you location A, location B, location C, location D, location E, and location F, you can answer which one of those is the asteroid moving the fastest. Ellipse number 4. Oh, that's why the yellow one was interesting. I just happened to grab it by chance. But it's the sun, so that's why it's interesting that it's yellow. So you should notice as I draw these things, there's no, if I drew a bad ellipse, it wouldn't look completely smooth all the way around. That would tell me I needed to redo what I did. So this is ellipse number 4, getting compared to Neptune's eccentricity or eccentricity. So in case you can't see, we've got a dot right there and a dot right there that you can measure. And then length of my major axis. And you can do your calculation and say which is more eccentric. I'm going to draw my sun right here. And we've got location L, M, N, O, P, and Q. So where would the asteroid be moving the fastest? Okay, so you can do some comparisons there, some calculations, and practice that out. Rewatch the beginning of the video if you're not sure how to do any of those things. Those are all the skills that are on our lab that we're practicing. And let me know if you have any questions. Yuri's upset that I didn't include him in the video. Sorry, Yuri.